Greetings and welcome to the lab introduction to the Chemistry 221 Identification of an Unknown Compound lab. This is kind of a fun exploration lab where you have some known chemicals and you now can figure out what the names are and the formulas and stuff like that. And you're going to try to identify which of the four knowns is present in your unknown. And you'll use a combination of a solid form as well as a solution form to identify it, looking for patterns of reactivity. It's a fun lab. Try to have fun with this lab. Should be cool. So in this lab, you and your lab partner or partners, remember you can work in groups of up to 3, will use 4 known compounds. They're all sodium salts. So sodium chloride is table salt. That's NaCl, and that's the most common probably. But you'll also use other salts. A salt is just an ionic compound, and these all have sodium for the cation, for the positive part. You'll have sodium carbonate, sodium sulfate, sodium hydrogen phosphate. And using the patterns of reactivity in your known compounds, you'll be able to identify which unknown compound you have. Now, the unknown compound will be one of the 4 known compounds, and it should have reactivity identical to one of the 4 knowns. Again, the 4 known compounds, they're all sodium salts, which means sodium is the cation. These are all ionic, so they have positive and negatives. NaCl is sodium chloride. Na2CO3 is sodium carbonate. Na2HPO4 is sodium hydrogen phosphate. And Na2SO4 is sodium sulfate. And you'll use these 4 knowns and their patterns of reacting with different chemicals to figure out which one represents your unknown compound. In this lab, you're going to have solid versions of the knowns and a solution version of the knowns. And of course, along the way, you'll also have solid and solution versions of your unknowns. Now, a solid is pretty chill. It's just a solid, like table salt is a solid. But if you take table salt and put it in water and dissolve it, your solid goes away. But of course, if you taste it, it would taste salty, like salt water. So salt water is a sodium chloride solution. Sodium chloride is called the solute, and water would be the solvent. A solute plus solvent goes to a solution. We'll talk more about that in another class. In this lab, the solution then will be the sodium salt plus water. Technically, NaCl with parentheses S next to it, that would represent the solid form of sodium chloride. And NaCl with AQ in parentheses next to it, that would be the sodium chloride solution. AQ is going to stand for water, if you haven't seen that already. Sodium chloride in water is the sodium chloride solution. And you're going to have versions of all of these knowns and unknowns present. So you'll have a solid version of the sodium salts as well as a solution version. You'll be able to write S next to the solid version and AQ next to the solution value. All of these dissolve well in water. That's why it works out really well. And solutions tend to react differently than the solids often. So that's why we're using both solids and solutions here to see what's happening. Patterns of reactivity are really important in chemistry because it can allow you to identify what an unknown is. So when you mix chemicals together, you want to look for things like the formation of a precipitate. Precipitate is just a solid that forms in a reaction. If there's a color associated with a precipitate, you definitely want to notice that as well. You also want to see if there's a gas formed, all right, bubbles, like fizzing, stuff like that. That represents some kind of chemical reaction. And you might be able to identify changes to the temperature. Probably things would get warmer, but you could also feel things get colder. Now, this is tough to do, and don't lose any sleep if you don't see any changes of temperature, but it is another way to identify some kind of pattern of reactivity. Now, a lot of combinations, though, won't have any reactivity at all. They'll just sit there, and that's very normal, all right? So in this lab, it's going to help you to really be observant for chemical reactions, and also just remind you, write everything down, all right? If there's anything that you think might be useful, you should write it down on paper, and you never know when it might be useful. So in this lab, mix the appropriate chemicals together and just observe for any changes. And again, some of them won't have any changes, but you could see solids, you should see gases and stuff like that. Safety glasses should be worn. You're dealing with some pretty strong acids and bases, so it's a good idea to be safe. And none of the chemicals today are fish friendly, so try to dispose all of the waste in the waste container in the hood. Don't put them down the drain. And again, you're welcome to have like a big beaker, and you can dump all the waste in there, and then at the very end dump the beaker into the waste jar, that'll save you from going back and forth all the time. But of course, it's totally up to you. The patterns of reactivity will help you to identify what the unknown compound is. So the unknown will be one of those four knowns: NaCl, Na2SO4, Na2CO3, or Na2HPO4. And your goal is just to figure it out, all right? And make sure that you write down the unknown letter that you get. We're going to use letters on this lab, I believe, and the letters will be really important, so write it down. If you have a pattern of reactivity that's not quite the same as your one of your knowns, it's a good idea just to repeat it, all right? So if you added, sulfuric acid to a chemical and it went clear, and another time you added it to a different compound and it was yellow, but everything else was the same, repeat that one experiment, all right? It's not a bad idea, because once in a while when you're doing experiments, there's a mistake made, and if you repeat it, you can confirm or deny what the actual results will be. So sometimes people have literally done this lab like twice through. It doesn't take very long if you're organized. It's a good idea then just to kind of repeat it if there's any questions. But most importantly, have fun with this lab. This is kind of a fun lab, all right? It's not real hardcore or anything like that. Just kind of look for the patterns and stuff, and of course, don't dump things down the drain, and it'll be a fun lab for everybody, the instructor included, of course. So at this point, let's have a little quick video that kind of shows how this is going to work. Again, you're going to use patterns of reactivity to see, look for precipitates form and stuff like that. Should be pretty chill. If you have questions on anything, let me know. I'm more than happy to help. There are no dumb questions ever in my class, so let me know. So without further ado, let's look at the video. Good luck with your lab.